Hello, Assalamu alaikum. Welcome to Redesign Engineering. Today I'll discuss about the theory of heat and mass transfer. I'll discuss only the definition parts today. So if you think that you are benefited by watching this video, please subscribe my channel, like, comment, and share. So let's going to start. The first one is the definition of heat transfer. Heat transfer is the transfer of thermal energy from a high temperature region to low temperature region. Second one is the mass transfer. Mass transfer is the transfer of molecules from from higher potential to lower potential. So now the definition of heat exchanger. A heat exchanger may be defined as an equipment or device which transfer the energy from a hot fluid to a cold fluid with maximum rate and minimum investment and running cost. It also the two types. The first one is the parallel flow heat exchanger and the second one is counter flow heat exchanger. Parallel flow heat exchanger. In a parallel flow heat exchanger, the two fluid streams, the first one is the heat and the hot and cold, which travel in the same direction. The two streams enter at the same entering points and leave the uh, ending point, same ending point. The counter flow heat exchanger. In a counter flow heat exchanger, the two fluid streams, hot and cold, travel in opposite directions. One's end position, it will be the another entering position. So the two fluid streams enter in opposite ends. Effectiveness. The heat exchanger effectiveness is defined as the ratio of actual heat transfer to the maximum possible heat transfer. So its the equation is given Q actual divided by Q maximum. LMTD means logarithmic mean transfer. Logarithmic mean temperature difference. So now the definition is going to start. This is a measure of heat driving force that creates the heat transfer. It is a logarithmic average of the temperature difference between the hot and cold circuit each end of the heat exchanger. So again, LMTD means logarithmic mean temperature difference. This is a measure of heat driving force that creates the heat transfer. It is a logarithmic average of the temperature difference between the hot and cold circuit each end of the heat exchanger. Heat capacity. This is a measure of heat needed to increase the temperature of a given mass of material 1 degree in Kelvin or Celsius. It is the product of mass of a material and is a specific heat capacity. Specific heat capacity. In another word, the definition is that it is the product of mass of a material and is a specific heat capacity. A specific heat capacity. This is the measure of heat needed to increase the temperature of exactly 1 kg of materials by 1 degree Celsius, or it is the ratio of the change in heat energy and the change in temperature. Heat transfer rate. The heat transfer rate is a function of the fluid mass flow rate, the temperature change and the specific heat capacity of the fluid at mean temperature. Energy balance coefficient. It is the ratio of heat absorbed to the heat emitted. It is the ratio of heat absorbed to the heat emitted. Temperature efficiency. Here also the another definition, temperature efficiency. It is the ratio of temperature change in the circuit divided by the difference between the maximum and minimum temperature of the hot and cold circuit. So again see temperature efficiency. It is the ratio of temperature change. ratio of temperature change in the circuit divided by the difference between the maximum and minimum temperature of the hot and cold circuit. Modes of heat transfer. There are three types of modes. So before going to start, see heat transfer, which is defined as the transmission of energy from one region to another as a result of temperature gradient, takes place by the following three modes. One is the conduction, another is the convection, and rest one is the radiation. So the definition of the conduction. Conduction is the transfer of heat from one part of a substance to another part of the same substance. In solids, the heat is conducted by the following two mechanisms. The one is the by lattice vibrations, and another one is the by transport of free electrons. Convection. Convection is the transfer of heat within a fluid by mixing of one portion of the fluid with another. I mean, it's apply on a fluid. So I can see convection is the transfer of heat within a fluid by mixing of one portion of the fluid with another. The condition is that convection is possible only in a fluid medium and is directly linked with the transport of medium itself. The convection constitutes the macro form of the heat transfer, since macroscopic particles of a fluid moving in space cause the heat exchange. The heat exchange. The effectiveness of heat transfer by convection depends largely upon the mixing motion of the fluid. Radiation. Radiation is the transfer of heat through space or matter by means other than conduction or convection. In other words, without conduction and convection, the heat transfer is called the radiation. It's electromagnetic. You can also say electromagnetic medium. See, the properties of the radiant heat in general are similar to those light. Some of the properties are given here. It does not require the presence of a material. Here no need to medium as a materials. So for transmission, radiant heat can be reflected from the surface and obeys the ordinary laws of reflection. It's obeys the law of reflections. It travels with the velocity of light. Like light, it shows interference, diffraction, and polarization, etc. It follows the law of inverse squares. So final was one. It is the out of syllabus of the heat and mass. The definition of the engineering. So engineering is the art and science of utilizing the material resources for the benefit of human being in the most economical and sustainable way. Thank you everybody for watching this video. If you think that you are benefited, please subscribe my channel, like, comment and share, and press the bell icon to get the new videos.